Congruency. Do you know this kind of thing? You can text, even you can call, okay? Tell. What is there? Do you know this kind of congruency? SAS, RHS, SSS, and ASA. Do you know this kind of congruency? No or not? Let me know. Don't know? Yes. Okay. Tell, okay, don't worry. I'll explain this congruency first. Okay. You have to know about this congruency. Okay. So take time. They are having four types of congruency I giving. Okay. So first of all, we have to know what are the congruency. Congruency means if you consider your left hand and your right hand, we can keep both of them one to another, no? We can keep both left hand and the right hand one to another, no? Same size, same area, like that one. So like here, congruency means the all the things are same each other. There are four types. Okay, there are four types. I divide by page into four. There are four types of congruency. I give you a summary like here. There are four types of congruency. What are they? I'll draw and show you. Okay, there are four types of congruency. The first type is like here. If I consider two triangles, okay, if I consider two triangles, otherwise I draw one by one. Okay, there are four types of congruency. The first one is side angle side case. There are four cases we discuss it. Side angle side case. What is that? Side angle side case means you can write with me, and you can consider there are two sides and one what corresponding angle with them. Two sides and one corresponding angle with them. Two sides and one corresponding angle with them, we are call it as what? Side angle side case. Okay, side angle side case. Okay, if I consider A, B, C, and this one I consider P, Q, R. Okay, look at it. If I consider these two sides and angles, what can you say? If I take in this angle is 100. Here also 100. They are given this side and this side equal, and this side and this side are equal. What is there? There are two sides and corresponding angle with them. Okay, you can write there if they are having two sides and corresponding angle like here. What is the triangles there? What are triangle? ABC triangle, and what is the other one? PQR triangle. If you consider ABC and PQR triangle, what can you say? What can you say? Here there are AB sides is equal for what? PQ side. It's given here, no? It's given. Okay. AP side is equal for PQ side. And next one, BC side is equal for QR side. It's also given. And the other one, the 100 degrees. What is there? That ABC angle and equal for what? PQR angle. It's also given. So you can see there are two sides, two S, and one corresponding angle with them. Two sides and one corresponding angle each other, equal each other. So you can write it as what? ABC triangle congruent. How to write congruent? There are two lines, okay, not equal. It's a congruency. PQR triangle. AB triangle equal for PQR triangle, congruent for PQR triangle. What is the case? Side angle, side case. Is that clear? You can write like this. What is the condition? It should be the side angle, side case. There should be two sides, and also it should be have corresponding angle. Not only the angle, okay, not only the angle, it should be what? It should be corresponding angle. Clear? It should be the corresponding angle. Can you write down that? Is that clear? Yes. Two sides and one corresponding angle should be. Two sides and one corresponding angle should be. Not only the angle, it should be a corresponding angle. Okay. Two sides and one corresponding angle. Okay, finish. You can think they are having two sides and corresponding angle. Two sides and corresponding angle. That angle should be placed in between the sides. Okay. Angle should be placed in between the sides. Okay. Clear?
Yes.
Okay. Can you see this one? Now let me know. These are congruents or not according to the SA's case. Can you just say? First one congruent or not? What can you say? Is first one congruent or not according to SA's case? What can you say? Okay, it should be here. There are mentioned two sides and two angle. There are should be actually corresponding included angle. Okay, included angle means two sides. Like here, if I consider these two sides, the angle should be placed here. Okay, angle between placed between there corresponding included angle. Yes. What can you say here? First one, congruent or not? Let me quickly tell. What can you say? This side is equal for this side. Okay, now this side is equal for this side. Okay, in between they are having a angle. In between they are having a angle. So this one is what? You can write congruent. Is that clear? It is congruent PQR angle triangle into the STU triangle. Second one, what can you say? You say, not me. Here, what can you say? First one, these two sides are equal each other. Okay, now, and next, these two sides are equal each other there. But unfortunately, this angle is equal each other. This angle equal each other, same place. But it should be what? It should be what? Included angle. So this one congruent or not? This is not congruent. If it is congruent, you have to mention which angle? This angle. You have to mention this angle because it should be included angle when you are consider SAS case. When you are consider SAS case, it should be what? It should be included angle. It should be included angle. Next one, what can you say? Is it congruent or not? Is that congruent or not? Say. Yes? Is that congruent or not? Said yeah. Yes. These two sides are equal, no? And these two sides are equal, no? But is that included angle? Included means it should be placed where? It should be placed which angle? These two angles should be. These two angles should be in between the considerable lines. So is this one congruent? Is this one congruent? Not. Next one. 5 centimeters, 5 centimeters equal each others. Yes. 8 centimeters, 8 centimeters, 8 centimeter, 8 centimeter. Between these two, there is an angle. Yes. 90 degrees. Between these two, there is an angle 90 degrees. Okay, now, this is what? Congruent. Is that clear? If I write it this one, 5 centimeter, what is there? YZ equal, what is the other one? LM. It is given as 5 centimeters. It's given as 5 centimeters. And next thing, 8 centimeter, 8 centimeter, what is there? XY equal for MN. It is also given. And 90 degrees, XY is at angle. XY is at angle equal for LMN angle. LMN angle. It's also given, so you can write what is the triangles. Here XY is a triangle congruent. Three lines LMN triangle. Okay, what is the case? SAS case. Side angle, side case. Is that clear? You can
Yes.
write if you want. Okay. Please watch this record again. Okay. Please follow this recording again. When I give in, please watch that recording. Okay. Quickly tell these three congruent or not according to SAS case. What can you say? Quickly say. If you are consider ABC triangle and ACD triangle. Here, this line and this line equal. Is there any line between them? Look at it. The both triangle they are having a common line. This common line is equal each other, no? AC is equal for AC. And between there they are having angle C here. They are having angle A here. So this is also congruent. Clear? That's also congruent. Here this side is equal for this side and this side is equal for this side and they are having two parallel line they are having alternate angle Z angle letter Z. Can you see they are having letter Z, so this angle is equal for this angle, two sides and corresponding angle, it is congruent. Here, this side and this side equal. These two sides also they have common line. It's also equal, but they are not mentioned. This angle is not equally. They are not mentioned. This angle not mentioned equal each other. So this is not congruent. Okay, like that all you can thinking. I don't take much time for that. That's the first case. What is that? SAS case. What is it? SAS case. And the second case is, I'll explain these things quickly. What is the second case? Angle side case. We call it as AAS case. What is that? AAS case. You have to consider two angle and one side between there. They are having two angles and one side between there. If I consider this kind of the two triangle like that. Okay. they are having parallel lines like here. I take it this one A, B, C, D, E. Okay. Now, what can you say? Any equal, any equality? You can clearly say they are having Z letter. Look at here. You can see a Z letter no? In between Z. If I consider Z letter there, like here, you can see Z letter no? You can see Z letter no? In between Z letter. These two corners equal each other no? In the Z letter, these two corners equally each other. That two corner is equally each other. So, what is the reason? These are calling alternate angle, no? Alternate angle Z letter. So, alternate angle are equal each other. So, for this purpose, you can see there is two angles equally each other. These two angles equal each other. They there are given one side, okay, this side and this side equally, and you can say another angle equally. What is that? These two angles should be equal each other. We call it what? Vertically opposite angle. Did you remember? Vertically opposite angles equal each other. So in this case, there are not considered two sides. Okay? In this case, that calling what? Angle side case. There are thinking what? Two sides and corresponding two angles and corresponding side. No need including one. No need including one. It should be have a same place. Two sides, two angles, and one what? One side. Here side, this angle in front of this. Here, C angle in front of, there are near to E angle. C angle in front near to A angle. Like that one, that side is placed in the same place. If you consider that one, if I consider what is ABC triangle and what is other one? DEC triangle. What can you write? That angle firstly BAC angle BAC angle equal for DEC angle. It's what? Alternate angle. It's what? Alternate angle. Alternate. Is it letter? It's a alternate angle. Second thing, in front of vertically opposite angle, what is there? ACB. If you consider upper triangle, it's ACB. Down one, DCE. It's calling vertically opposite angle. Vertically opposite angles. Vertically opposite angles. And the other thing, there are two sides you have to consider, AB and DE. AB and DE equal each other. That's given. Okay. Now, according to that one, there are two sides and corresponding angle. Sorry, two angles and corresponding side, and two angles and corresponding side each other. So you can write congruent ABC triangle congruent for DEC triangle, because of why? There are two angle and one side case. There are two angles and one side case. Can you write? Write down that quickly. Quickly write. This one call it what? AAS case. Two but angle and one corresponding side each other. Two angles and one corresponding side. So can you tell are them are congruency? What can you say? First one is this congruence. What can you say? First one, are they congruent? Each other? Here 70 degrees equal for 70 degrees. Okay, first thing. 60 degrees equal for 60 degrees. Two angles are okay. No issue. There's no issue with two angles. And this one, what can you say? One side, here also one side, placed between these two angles. Here between placed these two angles. So it is, so it should be what? It should be congruent. Why? The angle is two angles in between there one side. It is congruent. Second one, what can you say? One angle doesn't matter. Here one angle A, here one angle. There's another angle there. But here the angle in front, the side is mentioned in front of A and near to B. So this one also in front of M near to N. This side, if it is side is mentioned here, not here. If the side is mentioned here, it is congruent. Okay, otherwise you can place side here. So it is not congruency. Second one, not congruency. Okay, second one, not congruency. Third one, what can you say? Here one angle, here another one. Another angle, here another angle. Near to 90 degrees, there's a side. Here near to 90 degrees in front of this one, it's arrow having side. Same places, no? Same places. So it is congruent. It is congruent. Two angles and one side. A is case. Two angle and one side. Here one angle already mentioned. Is there any angle? What can you say? Is there any angle? Any angle? They already have one angle. Is there any angle? Yes. Look at there. These two. What are they? Vertically opposite angle. They are having vertically opposite angle. They already equal each other. This vertically opposite angle. Between there, they are having one line equal each other. So two angles corresponding one side. So it is AA is congruent. Clear? You can congruent each other with the AAS case. What is the angle, side case like that? What is that? Angle, side case. Is that clear? The second case. What is that? Angle, angle, side case. That's the second case. And the next thing, the third case. Shall we go for the third case? Quickly look after these things. Third case is very easy. We call it that one as SSS case. Can you imagine what is SSS case? SSS means two sides equal with the another two sides of another triangle. Three sides equal with another three sides of another triangle. Like here, side, side, side case. If I consider two triangle like here, I take it as again A, B, C this side and D other side. Okay. What are two triangle here? Let me know. A, B, C triangle and what is the other one? A, B, D triangle. Okay. There are two triangles. What can you say? There are mentioned these two sides are equal and these two sides are equal each other. Now can you say how to congruent each other? One line and one line. Both side. What is that? AC equal for AD. It's given. One line and one line. Secondly, two line and two line. What is that? CD is given for BD. It's also given. They are having common line. Can you see? They are having common line. What is that? AB is equal for AB. It's the common line. It's what? A common line placed between there. So ACAD, CD and BD. It's given CB and BD. No, sorry, here CB and BD and AB equal for AB both side. So you can write what? ABC triangle congruent to ABD triangle. What is the reason? Three sides each other, three sides. Side, side, side case. What is that? Side, side, side case. Three sides each other. Three sides each other. Can you write? Yes. Please write down third case. Okay, no, there are three sides are equal each other. That's calling SSS case. Three sides. Three sides equal each other. That's calling SSS case. Can you tell? Quickly tell these are congruent or not. Can you quickly tell these are congruent or not? These five. First one, 5 centimeters, 5 centimeters. Equally. 7 centimeters, 7 centimeters. Equally. 8 centimeters, 8 centimeters. Equal each other. Three sides equal each other. So this is congruent. First question is congruent. ABC congruent to PQR. Second one side equal for one side. Two sides equal for two sides. Three sides equal for three sides. So it's congruent. It's congruent. Here 10 centimeter, 10 centimeter, okay. Two lines, okay. But there are not mentioned this one is equal each other. There are not mentioned this one is equal each other. So we cannot say it's a congruent. Three sides should be equally each other. Side case, three sides should be equally each other. Okay. Here 1 equal for 1. 2 equal for 2. Another 2 is equal for another 2. So it's congruent. Here 1 equal for 1. 2 equal for 2. But here not mentioned. Here not mentioned. So it's not congruent. Here these are not congruent. Okay. So can you see? Can you get idea? That three sides should be equal each other. If that one congruent, that three sides should be equally each other. Okay. And the next thing is right-handed hypotenuse case. What is that? Right-handed hypotenuse case. We calling RHS case. Fourth one. Right-handed hypotenuse case. Okay. Here right-handed hypotenuse side case. What is the right-handed hypotenuse right case? What is that? If I consider two triangle like here, one triangle, another triangle. Okay, it should be hypotenuse, so it's have 90 degrees. Here it's given hypotenuse is 13 centimeters. In front of 90s, here 30 centimeters. This one 5 centimeters. Here this one given 5 centimeters. Okay, two things are okay. Here A, B, C. I take it this one P, Q, R. Okay. When you consider ABC triangle and PQR triangle. Okay. ABC triangle and PQR triangle. What can you say? When you consider ABC triangle and PQR triangle, what can you say? Here they are having nine. Here you have to thinking about two things only. You have to write only two things. What is there? There should be have right-handed. Okay, no, right angle. Yes, they are having right angle 90 degrees. In front of 90 degrees, they are having hypotenuse. This is hypotenuse. It's 13. In front of 90 degrees, they are having hypotenuse. It's 13. So hypotenuse equal each other. What is that? AC equal for PR. It is given and it's also what? A hypotenuse. You can write it as what? Hypotenuse. Okay, and other thing 5 centimeters equal for 5 centimeter. Another side is given equal each other. What is that? AB equal for QR. So it's given. So two things that hypotenuse equal each other and another side equal each other. So you can write ABC triangle congruent for PQR triangle. What is the case? RHS case, right-handed hypotenuse case. What is that? Right-handed hypotenuse case. Is that okay? Okay. You can write it as right-handed hypotenuse case. The fourth case. Can you write, please? Write it. That's a first case. Is that clear? What is the difference of cases? Okay. So you have to think about four cases. Right-handed hypothetical case. Now quickly tell these are congruent. First one, if I consider first one, what can you say? Here, in front of 90 degrees, 10 centimeters. Yeah. In front of 90 degrees, 10 centimeters. Hypotenuse equal each other. One side equal each other. So this is congruent. Hypotenuse in front of 90 degrees, it's hypotenuse equally. In front of 90 degrees, they are hypotenuse equally. Okay. So hypotenuse equal each other. So one side is equal each other. So hypotenuse and one side equal each other, both sides. So it's congruent. It congruent. Third one, can you say this one congruent? This one congruent? Can you say this one congruent? No, we cannot say because why? 7 centimeter, is there 7 centimeter? No. There are no. Here only what? Hypotenuse equal each other. That's the case. Here in front of 90 degrees, it's hypotenuse equally two lines. In front of 90 degrees, here hypotenuse equal each other. So hypotenuse equal. And another line equal. So this is congruent. So is there any hypotenuse? Next one. There are mentioned 90 degrees. If they are having hypotenuse, it should be mentioned this one is 90 degrees. Is there mentioned 90 degrees? No. Is there mentioned it has a right angle? No. So it's not a congruency. Clear? That are the four cases. Is that clear for you? The four cases? What is the four cases? I quickly tell. They are having SAS, side angle side. Second one, ASA, otherwise AAS, we calling angle side angle. SSS, three sides. RHS, right angle, hypotenuse. So what can you say here? Here all are given in the radius. These are the radius. What is the AO, AO, OC? They are radius. If it is radius, it should be equal. And the OC, and it's given AB and what? BC is equal each other. They are given these two is also equal each other. And here the common slide. So what can you say? Now tell me. What can you say here? If I consider ABO triangle, ABO triangle, and what is the other triangle? What is the other triangle? BOC triangle. BOC triangle. What can you say now? Here, one side, one line. AB equal for BC. AB equal for BC, it's given. It's given there, no? And second thing, two line. What is there? AO equal for OC. It's also given as a data. And OB is a common line. OB equal for OB, it's a common line. Common side. Common side. According to that one, you can write ABO triangle congruent to three sides. What is the BOC triangle? What is the case? Side case. Side case. ABO triangle congruent to BOC triangle. Okay, you can write like that. Clear? So what is the case? Side case. Okay, that's the thing you have to know. I wanted to explain. Last day also I did this here, but I quickly explained what are the four cases actually. They are having side angle side, RHS, SSS, and AC there. Okay, according to that one, you can take it as what? What? SSS case there. Okay, clear?
Yes.
Okay, good, great. Shall we move? Next question. Something good question. Actually, this may be a little bit harder. Yes. Can you start thinking, Alex? Okay, how to do this one? They are having P, Q, R, S are the points of the circle. Okay, I want to tell some theories also here. Some of them. I'll explain one by one. Okay, P, Q, R, S are the points. Okay, P, Q, R, S are the points on the circle. T, Q, U is a tangent. Tangent. Tangent always perpendicular for the what? Diameter. Tangent always perpendicular for the diameter. Keep in mind. Tangents are always what? Perpendicular for the diameter. Okay? Tangents are always perpendicular for the diameter. Now, keep this on good question. That's why I take it time. Okay? So, TQU is the tangent. Can you tell the answers? You can share me the answers if you know. Tangent circle is what? Tangent to the circle, and Q P R S Q intersects at the center of the circle. What is there? Q P R and S Q, yes, intersect on the center. Here the center point. Oh, PQ is parallel for the SR. These are parallel lines. Okay. Now they are asking QSR angle. QSR, show me. QSR angle. Keep in mind, there is have a theorem. Okay. If they are having a what? Segment like here. Otherwise, I will explain this one. I will give the reason why it's actually been like this. Okay. Look at it. If they are having what parallel line these things. Okay. If they are having parallel line these kind of things, you can say actually they are having two things. This angle is should be equal for interior what? Opposite angle. This one also should be 42. Okay, this one also should be 42. And where are the other 42s? This one also should be 42. We call it these two are what? First thing, this angle is equal for interior opposite angle. What is the if they are having a what tangent like that? Okay, if I take draw another thing to parallel line or something there, you can write with this one. Okay, if they are having angle in segment this one, it is equal for this one. and they are having same segment angle with the parallel line. With the parallel line, they are having same segment angle. These two angles are equal each other. First thing, this one equal for 42. This one also should be equal for 42. And other thing, this one also should be equal for 42. And POS, here, the next thing, if you know angles in the diameter, there's another theorem. There's if they are having angle in the diameter something, but here, if I consider another same segment angle, it should be going in the same segment. This center point angle is double of size this one. If I consider this one x, this one 2x. Same thing. Here there are 2 points. Consider these 2 points. If I consider this angle, it's 42. What is the center point angle when you consider these 2 points? Should be this one. It is double. If this one 42, this one should be what? This one 84. Double size. Got it? What is the theorem actually? There are three theorem I wanted to write. Okay, we will write firstly. Now first of all write the answers. Angle in QSR. QSR, show me. QSR is 42. Angle of PQS. PQS. Okay. What should be there? PQS also, if this one 42, okay, they are having same segment. This one also should be 42. It's also 42. And POS, it's double. POS, this one, it's actually double. It's 84. Okay. I'll explain what is the reason. 42, 42, 84. What is the reason? First thing, they are having a theorem that's calling what? Angle with the tangents. Okay, if I consider tangent. Okay, what is a tangent? A line that touching the circle. Okay, if I consider tangent, here the center point. If you consider one angle with the tangent, okay, there are having two parallel lines like here. It's better to connect it here. Okay, two parallel like here. What can you say? If they are having angle segment like this, if I consider this one x, what should be there? This segment also should be x. And other side, what is the reason? Here angles, corresponding angle is the tangent. Okay, corresponding angle with the tangent. Otherwise we call it same segment angle. One thing. And the second theorem, here the first theorem. The second theorem, if they are having same segment, what is the same segment? Segment same. Okay, the same segment. If I take the triangle, if I take a two parallel line, okay, two parallel line crossing like here, okay, two parallel line crossing like here, they are having a same segment thing. If they are having two parallel line like here, we can take same segment angle. If I consider here parallel line with here the other segment, what should be there? It is equal each other. This one x, if this one x. If I consider this one y, this one also should be y. What is the reason? They are having another theorem. Okay, they are having another theorem. You can keep in mind these things are very important. They are having another theorem that's calling that angle with the arc. What is the? So that angle with the chord. If I consider chord, that creating angle with these chords. Okay, if I consider one chord, that creating angle in the what? That creating angle with this chord. Look at it. That creating angle with this chord are equal each other. For the circumference, the creating angles with this chord. What is the chord? If I consider here the chord, that creating angle with the circumference. If I consider this one x, this one also should be x. So like here, if I draw a imaginary line of chord, look at it. If I draw imaginary line of chord, you can create two angles up in like here. It is equal each other. Clear? That's the reason the same segment angles are equal. If I consider imagine like here that two lines are equal each other. That's why we are calling this one same segment angle. What is that? Same segment angle. Same segment angle. Actually, they are not having chord, but we can imagine if they are having chord. Because of that one, they are it should be equal each other. So because of that one, we are calling that angles are same segment angle. I just erase them. Okay, so same segment angles are equal each other, x and y, and here also. Okay, I quickly tell that because of that reasons you can tell it this one 42, here also 42 degrees, and this is double 84. What is double reason? Double is the next theorem. If they are having a consider circle, okay. If I considerable circle, okay. If I consider one circle there, okay. Here the center point. If I consider one center point, if I take it 2 points, A, B, P, Q, anything, I take it these 2 points. According to these 2 points, if I create an angle to the center, here one thing. Same 2 points, if I create another angle to the what? The circumference. Any angle. Any angle. Sometime here, same 2 point, I create another angle like here. Clear? It's maybe going through this one. Doesn't matter. This, if I consider this angle and this angle should be equal. What is the reason? Same segment angle. Like previously, these two angles are equal each other, no? Is it fine? These two angles are equal each other. If I consider this one is a center point, the here angle is the angle on the circumference. Here angle on the circumference is double size the angles of the center point. If I consider this one as x, this one should be what? 2x. Clear? If I consider this one as x, this one should be 2x. The size is doubled. Is that clear? Size is double. Okay, I quickly give some work. Quickly. Wait. Hmm. Yeah, this kind of question. Okay. Take the idea, please. Okay, it may be a little bit what confusing, I know. But take the idea, please. I wanted to tell here tangents there. Sets from trigonometry, Pythagoras theorem. We calling that one something like the angles with the cyclic quadrilateral one times. Wait. I'll share. Read them. Please write down and read. Quickly. Can you tell me the answers? Here, here angle in the circumference. Here angle in the center according to these 2 points. What should be there? Angle in center 100. So circumference it's half. Circumference should be 100 divided by 2. It should be what? 50 degrees. Clear? If I consider circumference angle here, this one should be double. So x should be what? 30 times 2. 30 times 2. It is what? 60. What can you say here? If I consider 2 points. Okay, here the considerable 2 point. What is the angle of center? Angle of center point is what? 50. What is the angle? It's maybe going through the different places. Doesn't matter. What should be x? Here 2 points. It should be half of that one. So it should be 50 divided by 2. It's 25. Clear? Here the angle of the center. It's half with the angle of the circumference. Circle anywhere. Circle anywhere. Okay? But here circumference angle 30. It's double. Here center angle 100. So circumference angle half. Clear? Like that one you can draw them. Okay, please watch this one again. This is very important. That why. Now, can you say? Imagine 2 points. Or let's imagine 2 points. If I consider two angles, if this one 50, what is the other side? Here 360 minus 50, no? 360 minus 50. Altogether 360, no? Here 310. Here the angle of center is 310. According to these 2 points, that angle of circumference is half of 310. So x should be half of 310. Something different question. Think them. 155. Always thinking with the points. Okay. If I consider these 2 points, if this one 80, this one should be double. This one should be double. Here 160. Altogether 360. This one should be 360 minus 100 in 200. So this is half of that one. Here it should be 100. Good questions. Here, if I consider these 2 points, what can you say? Here angle of the circumference is 70. So here should be half of that one, here 35. But you can see these two are what? These two are radius. So because of radius, because of these two are equal, so in front of equal lines, the angles are equal. So this one equal for what? 35. These are theorems. Some of hard things. Somehow hard thing. I know. Okay. Please watch them again. Okay. Don't get confusing. Please don't get confusing. Please watch them. Take time. Okay. Please watch them again and again. We do lot of question regarding to them. Okay. And we will do other thing in tomorrow. Okay. Otherwise it confusing more and more. I know.